now we need to work on this end of the power connection. And again, this is AC, so it doesn't matter which end goes where. We do want to make sure that we don't get the wire into these screw holes. And so we're going to have it bent 90 degrees from this corner before this screw hole, so we don't have to worry about that screw getting into the wires. Now we did connect this temporarily, so we need to unsolder this. Because one thing you want to make sure that you do when you're connecting up power wires like this, you want to make sure that, because this is the fused connector, we want the fused connector to go up to the switch and then come back and then go to the hot lead of the transformer. In case the switch shorts out, it will blow the fuse too. Then we want to bend these up, so actually let's untwist these, because one of these is going to go to the transformer lead, and then the other one's going to go straight over here to this IEC terminal. And we'll probably do the one to the power terminal last, so we have a little bit of flexibility on the wire going to the power transformer. And we'll just have it go straight down like that. And so this one we can cut off about right there. Strip it back, bend down where it goes through, and then it can just connect down like that. And then this other one, I'm going to go ahead and go around one more time and then come down. And then it's going to be this black wire needs to connect to this yellow wire right there. And ideally, we want to put a little heat shrink tubing over the connection, which is going to be interesting trying to do and keep this all in tight quarters. But I think we can do it. So let's trim this off. Strip this back. And we can get a piece of heat shrink tubing and push it back on this when we solder these two together, and then pull it up together. So let me find a little short piece of heat shrink tubing. This black looks like it would be about the right diameter. See if we can slide that back over this, back down far enough where it's not going to be an issue. And I'm actually going to cut this little tinned piece off and re-strip this so I can wrap these around each other to solder them. There we go. I'm going to come in here and solder these together. Like that. Here we go. I can tuck back in there when we get solder that down. Now we can pull our little piece of heat shrink tubing up here and put it over our solder connection. Shrink that up. just like that. Loop like that. Solder that guy into there. And we'll be done. So I'm going to tin this lead just a little bit here. And heat that up. Go through that hole. Hold it while it cools off. And there we go. Not the prettiest thing I've ever done, but that should work just fine. Let me see if I can zoom in here to what the finished thing will look like. And there we go. This black wire is the hot lead of the power transformer. This is the neutral lead that goes to this lower pin, and then this blue wire comes from this pin, goes up to the switch. The yellow wire is the one that comes back and goes to the transformer. So really what we've got left to deal with is putting this little regulator over here, and hopefully this will be fairly simple to do. And then I'm also going to put a resistor in line to regulate the brightness of the LED to make sure that it's not insanely bright. Now we need to find if you look real carefully at the top of this, you can see there's a plus and a minus, and then the two on this side are the AC ones. And they're just like a little squiggly line. I think, it's hard to see. No, the squiggly line ones are on this side. That's the plus, that's the minus. So we want to nail this guy down to one side of this 6.3 volt, and then we're going to run a little short jumper wire over to the other one over here, and those will be our two AC connections. Like a lot of things I do, I'm going to tin all of these little pins on this bridge rectifier so that I've already got some solder on them. We're going to solder this guy onto this pin, and that's going to be used as our mounting point for the little rectifier. It's just going to kind of hang off this pin. Just like that. And then we're going to run a little jumper wire from this one over to this one. And let me find a little piece of wire to do that with. We'll just use a little piece of this blue wire to go across there. And I'm sure there's going to be some comments about the way I'm doing this, but you can do it however you would like. This is just how I did it on an earlier amp, and it seemed to work fine. And so I'm just going to replicate it onto this one. So I'm going to solder this end onto that side of the rectifier. Here we go. Then and that side's going to go right there. Just like that. Okay, got our AC hooked up. We need to connect these two to the power or the DC out on this rectifier, And then I'm going to put a really small little cap across these two pins just to smooth out the DC just a breath. And we'll be all done. And I know I'm probably doing this overkill, but again, you are welcome to do this in a different fashion if you would like. This surely is not important to the operation of the amplifier or has anything to do with what it sounds like. This is just one way of getting some power to this little LED. Okay, the back one is the negative. Let's be that pin. And I have a feeling things might get a little weird when I get ready to put the capacitor across here. The other thing, like I said, I need to put a resistor on the end of this wire. So I'm going to pause here a second and figure that out. Okay, so the next thing we want to do is we want to put a it turns out to be a 3.3K resistor, but anything right around there should work fine. That just dims the LED a little bit so it's not just screaming bright. And what we're going to do here is we're going to solder this resistor onto the end of this wire like that, and then put a little piece of heat shrink tubing on there to hold it together, or insulate it or whatever, just make it look a little nicer. So we're going to cut the end of that off real short like that, and then solder it onto the end of this piece of wire that we've got. Tin the end of this piece of wire. So then we come in and things wanted to spin around on me, and solder it together just like that. Then we're going to come back, get a small piece of heat shrink tubing, which that black's a little big. We'll see if I got something that fits a little better. I think this green will work nicely. And slide it over like that. And then shrink that down on there. Just like that. And there we go. Then we want to, this is going to come around like this. I'm going to bend this up a little bit of an angle. So it'll sit in there like that. And then solder that together. Okay, sometimes working on little stuff like this can be frustrating, so I'm going to show you a little technique that I've learned, and while it still might be a little frustrating, it makes it a little easier. We've got this capacitor here, and I've bent the legs up so that they line up going across these two pins. Now, if I try to solder this back one here, that wire's going to fall off. So what I want to do is solder this front leg to this capacitor first, with it touching in this back leg too. So we're going to come in here, and We've tinned up both these pieces. We got a little solder on the end of our soldering iron. Let's go ahead and clean the tip off, put some fresh solder on there. Come in here and solder this capacitor to this front leg. Like that. Let that cool off. Now, this capacitor is going to hold this other pin up against that joint, and hopefully we can come in here and heat this up while we're holding that wire in place, just like that. Now we want to check and make sure that, yep, the cap's attached, so is that wire. We've already put the resistor on the end of this wire. So now we should be able to come in here, hold this up, solder it onto this cap, and there we go. And this is just a little 100 UF. This is a 25 volt. It could be a 16 volt, whatever you may have laying around. And that just helps smooth out the DC a little bit. And when you're done, it looks like that. And I've gone ahead and tacked these wires down with a little contact cement. Let me zoom out here so I can show you. So I came in here and I've put a little tack here, there, here, over here. Just going to tack these wires down in the path I wanted them to go. And now we have our DC up to our switch. And now for the fun part, let's see what this looks like. This is just a quick review of the safety equipment that I use when I'm working on live electronic equipment. This is my Variac. The one I use has a 110 volt input, made in China one. I'm sure you can buy one for 2 or 3 times this much. It's made in USA, or you want to get a used one off eBay or something like that, you won't have to mess with the bucking transformer. But because this has a 110 volt input, and my house has 122 volt at that wall outlet, I use a 12 volt bucking transformer that brings the voltage down to 110 volts, so that all these readings on the knob in this meter in the front, but mostly I look at the knob, is accurate. And I've got a mark here for 120 volts, so I can turn it around there and get a pretty accurate jump to 120 volts when I want to. The next thing I have is a 1-to-1 isolation transformer. And there's different kinds of these. You need to be careful if you're buying the medical grade ones, because some of them do still keep the ground connected to the neutral. I know for a fact that this one doesn't. And it's got a 2-prong plug on each end. So make sure that if you, whatever isolation transformer you buy, that it actually does have the ground lifted and that it's not passing the ground through. Even if it doesn't have a ground lug or a ground pin, you need to make sure that the neutral is floating. That's the whole purpose of this, so that if something does happen, that you're less likely to have current pass through your body. I'm not saying it's safe to grab stuff, but you're less likely to have current flow through your body because the neutral is now floating from ground potential. The next thing I use when I'm, especially with an unknown piece of gear, is I use what's called a dim bulb, which is this thing back here that I've made, which is just a bulb socket screwed down to a piece of wood. I used a piece of an extension cord, or not a piece, but a whole extension cord to make up the dim bulb, and it's just across one of the wires in the cord so that if there is a dead short inside the amplifier, that's a current limiter and the bulb will light up instead of causing a dead short and possibly damaging something. One thing to know, that you don't want to leave the dim bulb in the circuit when you're doing your actual voltage testing for current draw and all of that stuff. Once you have the amp completed, it's good to have it in the circuit when you first turn it on, but once you see that the bulb doesn't like light up bright, you know there's not a dead short, take it out of the circuit so that you can get accurate readings on your voltages, because this is limiting the current and it will affect the voltage that you see like on the plate and the cathode of your tubes. So anyway, this is not a safety video. I'm just kind of doing a recap of the safety gear. Some people have commented, where's your isolation transformer, or blah, blah, blah. I'm showing you that anytime I have a piece of gear on the bench, it's running through all of this stuff. And once I'm sure that there's no short circuit, we take the dim bulb out. So the last thing I want to show you in this video is how cool this switch looks. So let me dim the lights and show you what that looks like. And while this was a whole lot more work than just putting a little toggle switch in the back corner of the amp, I think this does look really cool. So anyway, hope you're enjoying this series. If you are, please subscribe to my channel. It really helps me a lot. And also, like the video. And I'll see you real soon for some more 6SQ7 fun. Have a great day.